Hey guys, what's up? Welcome to TSK Tutorials, and this is FPS 1.39. So in today's episode we're going to be creating a script called enemy body. Now an enemy body is basically going to be a game object that each of the enemies are going to have. This is going to be a separate game object. It's going to start off as a child, and then it's going to unchild itself from that game object once the game starts, and then it's going to follow around that enemy. So we're going to be using some smooth down functions to make sure that the enemy body does this smoothly and actually moves around smoothly. And then also the enemy body, his feet are going to stick to the ground. So even though the actual enemy that's finding its way around the level and navigating and finding the player, even though that's sinking halfway through the floor, the enemy body is going to follow that enemy, find the closest position with its feet on the floor, and then move to that position in a smooth fashion. So we're going to be learning how to do that today. So yeah, why don't we pull up the script and get started. Alright, so here is the enemy body script. So let's take a look at the first few variables that we're going to be using. And the first one is move damp. Now this is going to be the approximate number of seconds it's going to take for the enemy body to move to the actual enemy. So this is just going to be a regular smooth damp function. As you can see, it is just the last parameter of a smooth damp function. So basically, the smaller this number, the quicker the enemy body is going to move to the enemy. It's going to move and it's going to snap to it really quickly. But if we make it a large number, it's going to be a lot more slow and smoothly make its way to where the enemy needs it to be. Now the next variable we have is turn speed. Alright, so this is the opposite of move damp. This number, the larger the number is, the faster the enemy is going to turn to the direction that it wants. If we make it a really small number, the enemy is going to very lazily move to where we actually want the enemy to point. Now we don't want this number to be so high that it immediately turns to where it needs to go, because that'll just look too glitchy, and we really want some transition time, because nobody can just immediately turn in one direction. They need a little bit of time to smoothly move in whatever direction that is. And then we have a variable which is parent to follow, and this is a transform. And the way we're going to set this up in the hierarchy is that we're going to have the enemy body actually be a child of the enemy. And then when the game starts, the enemy body is going to break off, or it's going to set its parent to null so that it doesn't have a parent anymore, so the parent-child connection is broken. So it's not going to be a child anymore, and it's going to be its own game object, but it's going to remember that, the enemy that was its parent, and we're going to save that in a variable called parent to follow. And then we have three variables right here, and I think about it, that's not supposed to be there. We only need the x and the z. But anyways, we have a velocity x and a velocity z, and those are both float variables, and these are basically just the two variables that we're going to need inside of a smooth damp function to keep track of the velocity. Alright, now let's move on to what we're going to be putting inside of function awake. So the first line of code is parent to follow equal transform dot parent. So as you can see, we have up here parent to follow is the variable that we declared up here of type transform. And then we have, then we're going to set it to save transform.parent, or the parent of the transform, because it's saved inside of the transform class. So we're accessing the parent that this enemy body has. And then the next line of code is transform.parent equal null. Basically, we are setting our game object to not have a parent, so it's no longer a child, it's its own game object. So when we set parent or transform.parent to null, basically we are breaking away from the enemy, so now we have an enemy and an enemy body. Alright, now let's take a look at our first two lines of code inside of function update. Now these two lines of code are basically identical, but one controls x, which is side to side, and z, which is forward and backwards, according to the world axes and not the local axes. But anyways, so we have transform.position.x equals smooth damp, or mathf.smoothDamp, transform.position.x, parent to follow.position.x, velocity x, move damp. So we have transform.position.x. For this line of code, we are affecting the x position in world space of our enemy body. and then we have a smooth damp function, and then we're going to give it the variable that we want it to currently be at or start at, and that is the position that we're at now. So we're going to do transform.position.x, which is the same thing that we have right here. So basically we're going to be smooth damping transform.position.x to parent to follow.position.x, which is the x position of its previous parent in world space. And then we have velocity x, and this is just a number that we don't need to worry about, just the smooth damp function needs to worry about to keep track of the velocity of the enemy to make sure everything's running smoothly. And then we have move damp, and this is going to be the approximate number of seconds it's going to take for our variable to reach its target, or basically the smaller the number, the faster the enemy is going to move to where it wants to go, and the larger the number, the more lazy it's going to be, and the smoother it's going to be, and the more it's going to take its time. And then we have the exact same line of code, except all of the x's were changed to z's, so I don't really feel like I need to explain that because it's the exact same thing, just on the z-axis. Alright, next let's smoothly work out the rotation of the enemy body. So we have transform.rotation equal quaternion.lerp transform.rotation parent to follow.rotation turn speed times time.delta time. Okay, so let me break this down. So we're affecting the rotation of the enemy, and we want it to move towards the rotation of the parent, or its previous parent, parent to follow, or the enemy that it used to be a child of. Anyways, so we want that rotation to match we want the enemy body to match the rotation of the enemy, but we want it to do it smoothly. Now we could have done a smooth damp function with a smooth damp function on the Euler angles of each the x, y, and z, but that would lead us to a few problems, like, let's say, depending on where the numbers are, we could have the enemy pointing this way, and the enemy wants to go this way, but because of the way the numbers are, and the way the 360-degree pattern, the enemy might do a full 180 to point that way. But we don't want that. So we're just going to use a simple quaternion.lerp function. Now, one thing I want to warn you is that this isn't often always the best solution, especially when it has to deal with the player and the camera, because it tends to lead to some very tiny, jittery movements. I can explain that later, why quaternion.lerp used every frame leads to tiny, jittery movements, but basically just know that it leads to tiny, jittery movements, and they are very visible when you do this on a camera. So only do it on things that are off the camera and generally kind of far away. In this case, we're not going to be able to see those tiny, jittery movements, so in this case, it's totally fine to use. So let me explain how this works. We have quaternion.lerp. Now, lerp is a function that is going to return you a variable that is somewhere in between the first variable you give it, the second variable you give it, and it is going to give you back a variable somewhere in between the two based on the third variable that you give it. So basically, when we have the third variable be turn speed times time.delta time, basically it's a very tiny number, so it's going to be moving just a little bit to get to the rotation that it wants to go. And then as it gets closer and closer, those steps are going to get smaller and smaller, and that's what leads to that smooth motion, kind of. So we have quaternion.lerp transform.rotation, the rotation that we're at now, parent to follow.rotation, the rotation that we want to get to, and turn speed times time.delta time, and we want to include the time.delta time because we want it to be based on actual time, not the number of frames per second that the computer is running at. And yeah, so this is going to be a tiny number that's just going to move this variable to eventually match up this variable. So yeah, I kind of jumped all over the place, but hopefully you guys should generally understand how this line of code works. So yeah, let's move on to the last for loop system that we're going to be establishing in our next few lines of code. Alright, so let me explain exactly what everything I have highlighted right now is going to do. So basically, every single frame, we're going to be shooting a raycast starting way above the enemy's head, going straight down, and that raycast is going to be a raycast all function, which means it's not only going to return the first collision that it finds, it's going to return every single collision that it finds, and then we're going to sort through all those collisions, and then we're going to find the one collision that is the enemy's current cell, and then we are going to set the Y position of our enemy body to exactly match up that point. So basically the exact position of our enemy body, its 0, 0, 0 point is going to be exactly on the floor where it currently is. So let's start. We're declaring a variable called hits, and it is of type raycast hit, and we have an opening and closing square bracket to show that it is going to be an array. So we're going to save multiple raycast hits variables inside of this one raycast hit variable because it's an array. Alright, and then we're going to be affecting that variable, so hits equals physics.raycastAll ray transform.position plus vector3 0 100 0 comma vector3 dot up times -1. Okay, so the way we are going to do it inside of raycastAll is that we need to give it a ray. So that's why we have declared right here ray, and there's two parameters to array because basically array is an origin and a direction. So right here we have the origin, which is transform.position plus vector3 0 100 0. So we're starting with the position of where our enemy body is now, and then we're going to be adding the vector3 0 100 0 because that is going to be 100 units, which is, for the most part, that's probably going to be a lot of units. Depending on your game, in case you change the scale of your game to be something a lot larger, you might need to change this variable, but in most cases, 100 should be a good number. You could also do 1,000 or 10,000, really doesn't matter. But basically we need a point that is going to be straight above the enemy's head and really high above the enemy's head because we want to make sure that we get the collision exactly. Alright, and then we have vector3 dot up times -1. So vector3 dot up is basically short for 0 1 0, or a magnitude directional vector that is indicating pointing straight up. So when we multiply that by -1, now we're pointing straight down. So that is going to be the direction of this ray. So the origin is where we are now, except really, really high up in the air, and then the direction is straight down. So now we have a ray that is going to start high above our head, go straight down, and find all of the collisions that basically go through the center of the enemy's body and all the way down, and it's going to find the floor. Alright, next we need to set up a for loop system. So we have for I equals 0, I is smaller than hits.length, I plus plus. So, oh, I did not declare the variable I, did I? So I think we need the word var right there. So var I, and let's just declare that as type integer. Int. Yeah, well, we'll figure out in the Unity screen recording. But anyways, so we're declaring the variable I, and it is starting at 0. And then the condition, which is if I is less than hits.length. And then at every time we run through this whole loop, we are going to increase I by 1, and I plus plus is short for I plus equals 1. Alright, and now inside of the loop, we are going to declare a variable called hit. Now make sure that you notice that there is no S at the end of this word hit, because now we are only looking at one raycast hit at a time. So, we're going to do var hit of type raycast equal hits I. So the I is inside of the square brackets, so this is going to represent the raycast hits in the list of the raycast hits that we have, and then it is going to go through and swap this out each time we go through this for loop and save it inside of the variable hit. And now let's actually test that variable hit. So if hit.transform.gameObject equals parent to follow.gameObject.getComponent enemy movement.current cell. So we have hit, which is a raycast hit, which saves a bunch of information, and one of the bits of information it saves is the transform of the collision that it found. Or collision really isn't the right word, but whatever the raycast hit found, or the hit, it's going to find the transform of that, and then we want to access the game object from that transform, and then we're going to do parent to follow dot game object, so we're accessing the game object because parent to follow is a transform, and then we're going to do get component enemy movement, and I believe that's supposed to be enemy movement script, so script, whatever you want to name it. So get component enemy movement script dot current cell, so we're finding the current cell that the enemy is currently in, because that's the only cell that we want to be testing for. So as we go through all of the hits that we found from that raycast, if any of them equal the game object that is the current cell of the enemy, then we are going to run the next line of code, which is simply transform.position.y equal hit.point.y. Now hit.point is the exact point that that raycast hit actually hit in X, Y, and Z in world space. This is a vector 3. And we're going to access the Y axis out of that because that's the only thing we're interested in. We just want to match up the Y position on our transform. And now basically our enemy's feet are always going to be on the ground. So I believe that's all the code that we need to go over today. So now I'm going to cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity, and the first thing we want to check out is to make sure that all of our cells are pretty much as close to the ground as physically possible. So let's go ahead and lower it. Well, I'm pretty sure all of these are at the same height, so I'm going to select all of them, all the green ones. It doesn't matter about the blue ones, so the cells, not the doors. And we want to lower them just so that they're paper thin and they are just resting on the ground. So yeah, I think that's pretty much good. So now let's, well, first of all, I didn't, oh, what just happened? Okay, so I didn't make the enemies a prefab, so I'm going to select all of those and delete them, but I kept one. I kept a 1 right here. And I'm going to modify this one. So I'm going to, first of all, I'm going to create an empty game object. So create empty, and I'm going to call this enemy body. Body, there we go. And I'm going to set that as a child of the enemy. And I also want to turn off the box collider of that enemy, because that was getting in the way of the last episode. I'll probably eventually just delete that cube, but for now I kind of want it in place so that I can make sure that the enemy is looking forward in the right direction so that we have some visualization. Alright, now I want to add some cubes. So game object, create other cube, and I'm going to call this enemy, I spelled that right, enemy body cube. And I'm going to set that as a child of enemy body. So this game object right here is going to represent what we actually want the model to be. So in this case, I'm just using cubes, but if you're making an actual game, you're probably going to want to use an actual model and not a cube, because cubes really don't work that well. So yeah, let's see. Let's select enemy body. Let's set this to pivot. So when we set that to pivot, we are actually looking, this X, Y, and Z movement tool lines up with the origin or the 000 point of the game object that you have selected. And when it's set to center, it is giving you the average between this and all of its children. So I want to set that to pivot so I can see where its feet are. And then cube, I'm going to assume that's generally close enough, and I'm going to duplicate that and resize it and move it around. And basically, I'm just going to give the enemy a nose. So now we can actually see which way is forward for the enemy body. Alright, cool. So now let's create a script. So create JavaScript enemy body script. And let's attach that to the enemy body. And now we have the script ready to go. So I do want to point out that just these two cubes, they don't have to be cubes or anything. Whatever is a child of the enemy body, it doesn't matter. Later on, you are probably going to want to add some correct colliders there for bullets to hit it. But these can be replaced. They don't have to be ugly cubes. They can be actual game models. So just want to make that clear. And now let's actually edit the enemy body script. So let's go ahead and delete all that and make our variables. And the first variable was move damp. And it's going to be a float. And let's have that equal 0.1. And next we had, I don't remember what it was, parent to follow. I think it's spelled follow around, but whatever, I don't care. Transform, alright, and, oh, I'm at such a loss. Okay, I will just go over here, and FPS 1.39. Alright, turn speed, that's the one I forgot. Var turn speed float equal 10-ish. Okay, and now we need velocity x float and var velocity z, and that's a float. Alright, and is that all the variables? Yes. Alright, now let's do our awake function. Function awake. Alright, so the first thing we want to do is save the current parent. So we have parent to follow equal transform dot parent. Whoops. Alright, so we're saving inside of the variable parent to follow, and we are accessing the transform that this particular script is attached to, or the transform that is attached to the game object that this script is attached to, and then we are accessing the parent of that transform. And now we want to set the parent to null. So transform dot parent equal null. And null is just another word for nothing. Alright, cool. And now let's actually get into moving the enemy around. So transform dot position dot x equal math f dot smooth damp, and the variable that we want to start from, which is transforming position dot x, and we want to move to parent to follow dot position dot x, and we need a velocity of velocity x, and smooth damp is going to take care of keeping track of that variable for us. And the last thing we need is move damp so that we can control how quickly or slowly the enemy actually moves to its parent. So I'm going to copy that, and I'm going to paste it, and I'm going to change all of these x's to z's. And make sure that's a capital Z. Alright, looks good. Let's go ahead and give that a quick test run. I'm going to save that. I'm going to zoom out a bit so that we can see it. And now it looks like it's working. Let's go over here and give it a little bit more of a test. He doesn't see me yet. Does he see me yet? Now he sees me. So now it might be a little hard to see. And the Y position of that enemy has yet to change. And let me go ahead and pause it. So the game is still running, but it's paused. And as you can see right here, enemy body and enemy are now separate game objects. That happened in the very beginning of the game. They're completely separated now, but the enemy body still remembers the game object that used to be its parent. So now let's go in and let's smooth damp the rotation. So transform dot rotation equal was it quaternion dot lerp from where it is now, so transform dot rotation, and the target that we want it to move towards, and it was parent to follow dot rotation, and the speed at which we want it to go, which is turn speed times time dot delta time. Whoops. There we go. Okay. So I just wanted to quickly make a note of this one more time in case you jumped to the screen recording and didn't watch the green screen part. I really want to make it clear that this function only works sometimes. I mean, well, it's going to work all the time, but it's going to work best only sometimes. Never use this function for things like cameras or anything that's going to be close to the camera or something that's going to be very visible, because this does cause small jittery movements and it's not completely smooth the way smooth damp is. So never use a function like this on a camera, because that would just look really bad. But in this case, we won't be able to see the small jittery movements of the enemy because they're pretty far away. So yeah, let's go in here, and it might be hard to see on the screen recording, but it is definitely smoothly looking in the direction. Instead of it immediately jumping to where it wants to look, it takes a second to look at where it wants to look, if that makes sense. Okay. And now let's actually affect the Y position of where we want the enemy to go. So we're going to declare a variable called hits, and it is of type raycast hit. Did I spell that right? Maybe raycast is all one word. Hit. Yep. Okay. And it is going to be an array. Alright, so now hits equal physics dot raycast all. And we need to give it array. And its origin is going to be transform dot position plus vector, vector 3, 0, 100, 0. And the direction that we want it to go is going to be, what was it? Vector, 3 dot up times -1. Alright, and I believe that line was done correctly. Let me just double check that. I did it, yes. Yes, I did that correctly. Okay, now we need to create a for loop. So for var I int equals 0, and the condition is I is smaller than hits dot length. Did I do that right? I don't know. We'll see. I'll get errors if I did it wrong. And then I plus plus. Oops. Plus plus. There we go. And okay, now let's actually look at what we're going to be putting inside of here. So we want to declare a variable, and we're going to call this one hit, not hits. So hit is of type raycast hit, and we're going to have it equal hits I. So now the variable hit will be swapped out with all of the different items on the list of hits. And now let's actually test hit. So if hit dot transform dot game object equals what was it? Parent to follow. No, messed up. Why can't I type? Parent to follow dot game object dot get components and enemy movement script dot current cell. All right. So if the hit that we just found is the hit, or is the game object that is the current cell inside of the enemy movement script, then we will run this next line of code, which is transform dot position dot y equals hit dot point dot y. Cool. So let's give that a test run. I think it's gonna work. We'll see. Looks like it's working. The enemy is staying where we want it to, or at least it looks like it. Yeah, it looks like it is. The actual enemy is moving up and down, but our enemy body is actually staying on the ground. Cool. Oh, and I forgot to take off the colliders off of the enemy body. So let me turn off those colliders. And why don't I make that invisible and that invisible? So now our enemy should look kind of cool. Let's take a look. Where is he? There he is. Sup, dude? Do you see me yet? Really? He doesn't see me? There, now he sees me. He's coming after me. And he's staying on the ground. And it looks like it's generally working pretty well. Cool. Alright, one thing I actually want to change. I just changed my mind about how I want to do this. So I'm actually going to change the rotation. Alright, so I'm going to do... Okay, so parent to follow dot rotation. What we need is a target rotation. And so we should make that target rotation. How are we going to do this? We want it to be based off of the parent to follow rotation, but we want it to be looking forward. Do we have a last position somewhere in here? We might need to create a last position. Oh wow, this is so much code. Alright. Where is last position? Okay, last pose equal transform dot position. Okay. So I think we can do this. Enemy body script. So I'm going to... No, I'm going to create a new variable called var parent enemy movement script. And we are going to have this be of type enemy movement script. And then I'm going to create a variable. I mean, not create a variable. I'm going to set that variable to, so parent enemy movement script equal transform dot parent dot game object, because parent is a transform, so we need to get a game object, and now we're going to get a component dot get component enemy movement script, and there we go. So now we have the enemy movement script saved, so now that shouldn't slow down our code as much when we access last pose in all of our thingamajigs. I lost my train of thought. Thingamajigs is not a technical term inside of Unity, just to let you guys know. Okay, so where was I going with that? I'm making this up as I go. This happens sometimes. Okay, so parent to follow. Okay, so now we want the target rotation. So we're going. Oh, we want to create a variable called target rotation. Var target rotation. And this is going to be a quaternion. And we want target rotation equal quaternion dot look rotation. And alright, now we need to give it a forward. So we are going to give it what's it? Parent. Put a space here. Parent. There we go. Parent enemy movement script dot last position minus. I might have this backwards. We'll know. Parent to follow dot position. And we want it to, by default, have a vector or an up of world space up, so we can go ahead and leave the next parameter blank and just give it a forward rotation. Now we want to copy and paste that and place it there. So now instead of lerping to the parent to follow rotation, we are now lerping to our target rotation. So I think I have everything right. So basically everything I just did there is now eliminating looking up and down. So now our enemy is probably not going to be looking up and down and doesn't look like the enemy is looking in the right direction at all. Okay, look rotation viewing vector is 0. What? Alright, the last position and the current position don't match up apparently. Alright, well, I guess I will create a last position inside of this particular script. So I guess I don't need this variable. So I'm just going to create a variable called parent last position. So parent last position, or last pose, and I'm going to change this to parent last pose, and it's going to be a vector 3. Okay. And is this gonna work? Yeah. I don't even know if this is gonna work. Okay, now it's working. I just had to cut the editing and actually figure things out for a second, but I got it working. So basically I'm going to point out all of the changes I made from what it looked like. Oh, what's this doing here? That needs to be deleted. Okay. So I'm going to point out all the changes that are different from what I showed in the green screen recording. So basically I added 2 variables. I have parent last pose, or parent last position, and target rotation, and this is a quaternion. So the way that this is going to work is that we have these 2 lines of code added and this line of code modified. So we have, first of all, target rotation equal quaternion dot look rotation parent to follow dot position minus parent last position. And then we have after that, and it is very key that you put this line after this line in order for it to work. Parent last position equal parent to follow dot position. So basically when we access parent last position in any line of code that is before this line, we are accessing the position of the enemy during the previous frame. So, and then we are going to compare that against its current position. So when we minus the last position from its current position, now we have a vector 3 that represents the direction from where it was to where it is now. And then we are doing a look rotation from, oh my god, I just realized that I didn't change anything. That was stupid of me, and I probably should just do this whole screen recording over again, but I am way too lazy to do that, so I'm just going to show you the more lines of modification that I did and that I edited out. So anyways, so I am creating two new variables, and they are temp parent current position and temp parent last position. So temp is basically short for temporary, and that's because we are temporarily saving the current position and the last position, and then we are going to set the y to 0 on both of those. So we're declaring a variable called temp current pose type vector 3, and we're going to set it to parent to follow dot position, so where the enemy is currently at right now. And then we're doing the same thing, temp var temp parent last position vector 3, and then we're going to have it equal parent last position. And then we have temp parent current position dot y equals 0, and same with on temp parent last position, we're setting the y to 0. So they're going to be in the exact same position, except on a 0, 0 2D plane. So this is going to eliminate the need for the enemy looking up and down, because we want the enemy to do any looking up or down movements with their neck or their head and not with their whole body. So that is why I threw all of those lines of code in place. And now that we have all those lines of code in place, I put, I swapped out, what was it? Parent to follow dot position with temp parent current pose, and parent last pose with temp parent last pose in this line of code right here, and it appears to be working. Okay, that was a headache, and I really should have planned ahead doing that, but you guys know me, I really like to spontaneously add new features to the game and not plan out ahead of time. But yes, our game seems to be working, and I want to redo some level design and actually make a ramp so that we can really see how this system is going to work. So I'm just going to expand this. I'm just going to change this into a ramp. So I'm going to stretch that and tilt it. And that's, I don't really think it makes much of a difference. So there we go. And I'm going to duplicate this, and I'm going to move it. Actually, you know what I should do is I'm going to focus in on this, and then I'm going to move that to where my camera is, and then I'm going to tilt it until their angles are pretty much even. And I want to set that to local. And oops, I can see now that it's not perfectly even. I don't know if I can get it perfectly even. Well, I can by copy and pasting the rotation. So copy and paste, except that is backwards. It's very close, but it's backwards. So I'm going to put a negative symbol. Let's see if that works. No, it does not. Okay, screw that. I'm just going to get it as close as I can, because I really don't think it's going to make a huge difference. Have that just barely be floating above. And now I need to rescale it a little bit more. Okay, that looks like it'll work pretty good. And I'm going to duplicate this, and I'm going to put it right there. I think that'll be good. And now what do I want to do? I want to create kind of like a platform going on over here. So let's resize it to be about the same width. Actually, it would be the same width as the cell, so the player doesn't really have anywhere to go that the enemy can't. And let's move that over here. Now let's duplicate this. Almost done. Now, see if that looks good. We scooched over a bit. It's not perfect, but I think it'll work. Alright, now, yeah, I think that will work. So let's see if the enemy can now follow me up this ramp. So I'm going to go over here. Enemy, come on, look at me, look at me. Now he's following me. And now I'm going to move up here. I didn't put any up, yep, and he's following me up. Seems to be working pretty well. He knows where to stick Y, or on the Y axis, he knows where to go. So yes, this pretty much proves that our code is working. Now, of course, I would want to put those, what did I call it? Stair ramp going up and stair ramp going down game objects right here. But you guys don't need to watch me do that. But yes, so this has been ETSki Tutorials FPS 1.39. So hopefully my next episode goes more smoothly and I plan out a little better. So until then, I'll see you guys later and keep making games.